Good morning, good afternoon, good evening, good night, wherever you are watching this video from. Yeah, today I'm going to explain the data visualization and dashboarding in Python using EMR datasets as we have been working on for the past 3 weeks. So today I'm answering the question that I shared with you. So the first today you will see different charts. We are going to look at bar charts, pie charts, scatter plots, the trend, and histogram. So and we look into the key performance indicator. So let's start with question one. Question one, create diagnosis count bar charts. So you use the CBOS library, which is SNS. So I use count plus data. My data is ML data set, and my S is diagnosis. And I use PRT to plot the charts. As you can see here, we have diagnosis, heart disease, kidney, and diabetes are the most diagnosed in the data sets. And we repeated the code because they ask us different questions, but it's likely the same thing. So what I did in the second question was I changed the diagnosis to department since that they said that we should create a department count bar chart. As you can see, the charts, and when you look at these bar charts, you could see that there was not so much differences between the pediatric, oncology, and cardiology, and neurology. So the question that I would like to ask you that, yeah, you should try to add the title. I won't do that. I want you to do that. You should add the title. You should label it too. And the third question is the same thing. The only thing that I did there was I changed the department to insurance type. Apparently, we have Medicaid, the most used insurance type by the patient. And for the question four, rate average treatment cost charts. We use bar plots for that, and my data set is ML data set. We have S axis and Y axis here, and we are calculating the average means. Apparently, you can see that we have for the S axis diagnosis, while the Y axis is treatment cost. We look at the bar charts, you see that you add all the charts that's here you come across here. I want you to add the title chart. If you want to add the label, that's fine by you. So you see there was not so much differences between them. Only diabetes is the average treatment cost, let's say something like 28,000 dollars. So for diabetes. So question five, create average length stay chart. This one is length of stay. Maybe stay or length. Let me see. Length of stay. Length of stay. So what I did, the code that I wrote previously, I copied the code and I came down here to paste it. The only thing I changed there was the first one was diagnosis and treatment cost, while the second one was department and length of stay. So you should add the title to it so that it will be easier for you to read. That is the assignment for you guys. So within departments and length of states, ecology and emergency. So I think those two departments, they have, well, we can add primary care too. They have a longer stay in the data set. And when we come to question 6, create age histogram, you use plt.east method. So you call the column age and your bins is equal to 20. So this your bins is 20. So plt.show. Apparently you can see the histogram, the distribution. That's from 0, let's say 0 point something down. You see the histogram is wave is high here, down here, increase here, decrease here. You say the distribution of age. So let's say the highest age is between can say 0 to 0 to 2. The highest age, because the pin is down here, the age is here. Let's say 30. Is it 38? Yeah. The highest age, that is the distribution of age. Likewise, for the question 7, create treatment cost histogram is the same thing. And question 8, heart rate histogram. So I copied the code. The only thing I'm changing there was the column's name. So the same thing to the left of set. When we look at question 11, ask us to create diagnosis pie charts. We created for the diagnosis for the pie charts in our first, yes, this one. This is the pie chart, while this one is pie charts. So the pie chart shows the percentage, while the bar chart shows the numbers. You understand? If you want to read your charts, okay, you want to read by percentage, I will recommend you to use a pie chart for it. Apparently, from the pie charts here, you can see that kidney disease has 15.1%, heart disease 14.5%, and diabetes 14.5%. Those are the three diagnosis that has the highest percentage in the data set. Likewise, the same thing with age. We could see that male has for 51.2% in the data set, male patient. And for the insurance type, yeah, we created the bar chart for it, but this one is pie chart, and Medicaid had the 28.6% patients using Medicaid, so in the data sets. And for the departments, we created bar charts for departments earlier, and this is the pie charts of it. Like I mentioned earlier, that we have 3 departments that has the highest number length of stay. Okay, the one we created before is a length of stays, that which department has a length of stays. Or so for the pie charts, apparently from the data sets, we could see that we had neurology, oncology, pediatrics, and cardiology that there's no differences between those 4 departments. they have the same, let's say the same, because neurology and oncology has 70.0%, while pediatrics 70.4%, cardiology just a slightly differences. So when we come to age group, yeah, the patients in the data set, we have the highest patients fall between 65 years above. We had 25% of patients with 65 plus above in the data set. So while 0 to 18 years old fall between 24.5%. So our patients from the data set, when we look at the age group, we have 24.4% of 0 to 18, while 25% of 65 plus. So this is a bar chart for treatment course, and bar chart, we have minimum year as 0. Yeah, and we have a maximum year of 50,000, and the median year Q1 for between $13,000, while Q3 year for between $30,000, and the median is for between 25%. There's not outlier here. Any data that is far from the data set, we call it outlier. I think we'll see something. So likewise for the question 17, I just copy the first code and I pasted here. So change the column to arch width. Likewise for the length of stay, likewise for temperature. So question 20 outlier from the treatment course. From the treatment course. So apparently, when we look at the treatment course, Q1, Q3. So Q1 is 25%, 75%. We minus IQR, Q3 minus Q1. Outlier. So there's no outlier from the data set because we have 0 rows and 27 columns. So there's no outlier in the data set. So question 21, plot age versus treatment. We use a scatter plot for this using Seapon library. So we have x-axis as age, y-axis as treatment cost. Apparently, you can see that there's no direction in the scatter plot because when you want to read the scatter plot, when positive relationship, if as age increase, the cost increase. So dot slope upward. For example, when age increase, cost will increase. That's positive relationship. But when you want to get the negative relationship, when age increase like this, treatment cost will decrease. That's a negative. However, if the dots here are scattered randomly, there's no clear direction. You understand? So, for example, this scatter plus there's no relationship between them because they are all everywhere. The same thing for this question 22, question 23, no direction. So there's no positive or either negative relationship between the heart rate and temperature because these dots are scattered randomly. Likewise this. So question 26, heat map. So you find the correlation between it. Use examine relationship among numerical variable in the art scale dataset. Most correlation coefficients are close to 0, indicate weak. no linear relationship between the variable. The correlation between age and treatment cost minus 0.04. So the age is very weak because minus 0.05 is a weak, very weak relationship. So that the age is not significant predictor of treatment costs. The relationship between length of stay and treatment costs is length of stay and treatment costs. We have 0. Yes, length of stay and treatment costs year. So it's also weak, indicates little association between hospital stay during and treatment expenses. The higher positive correlation observed between weight and height is 0.8. Weight and height is 0.8. Yeah, they have a strong relationship. Yeah. 0.08. Although the relationship remains weak, overall, the heat map suggests that no single numerical variable strongly influence another. An additional factor such as a diagnosis, treatment type, and patient condition may better explain variation in treatment costs and health care outcome. Interpret a stronger positive correlation. Identify the larger positive value close to +1 in the heat map. Variables with this value increase together. For example, so for example, age to age, they have 1. So, and interpret stronger negative when they have contain -1 in the heat map, one variable increase and another one decrease. So combine bar chart, question 29, combine bar chart, histogram, box plot, scatter plot, and KPI summary into one dashboard using matplotlib and cpop. So this is the code that I wrote here. So I created the axis first from the code, and my first is the KPI. I look into the total patients, average age, average cost, average stay. And my second chart contains bar plots, while the third one contains the pie chart. I have histogram for the age, distribution, box plots for the danger and treatment, and scatter plot for age and treatment. So this is how the dashboard look like. So my question for you is that for the average treatment cost by gender, I want you to add the title to it, and you can label it if you want. Treatment cost by gender, I want you to add title to it too. And for age distribution, there's title there. So my question for the summary, I added the summary here. So, and the question 30, I wrote 10 business insights. So the 10 business insights here, I would like if you can create your own dashboard, create 6 different questions and create the dashboard. You can submit it before Friday. I will look into it. Thank you for watching. So we are starting SQL next week by God grace. I'm going to send you the guidance for the how to install the instruction, how to install the SQL Server and the SQL management to do. Thank you. See you on Saturday. Bye.